Alright, so let's continue now to factor in the difference of two squares. So looking at the simplest, question, that I could find really, and also to illustrate the concept, I think a square minus b square is ideal. So the answer is just a plus b, a minus b, and that's the answer. But I guess that wouldn't be helpful to just write that down. So let me show you that this is indeed the case, right? So just to prove to you that this times this give you what we have at the top here, a square minus b square, I'm going to expand the brackets. So a times a square, a times minus b, minus ab, right? So you remember that whole distributive, law, and how we would normally distribute, terms like these, to expand the bracket. In other words, to remove the bracket. So the next term would multiply, or would be the b. So this is b times a, which is the same thing as a times b. So we can just write ab, positive ab. And then b times minus b is minus b squared. Now the middle terms cancel, and we are now left with a square minus b square. So it indeed works, right? And so the lesson to really get from this is that whenever you have a difference set up like this, where you have a square minus b square, the answer is just, as we had before, a plus b in bracket a minus b. And that's just the answer. Now let's apply that principle to this question. So first we will rewrite this as x squared minus 3 squared. Now think of this x as a and this 3 as a b, as in the question before. So it's in the same setup, a squared minus b squared, the same form, x squared minus 3 squared. So your answer would just be x plus 3, x minus 3. And that's it. So on to another question. So applying the same concept. Now the only tricky part about this is that there is a number in front this a square. So before we would see a square, by itself, and would be just straightforward. Similarly, here's another number. So all we have to do is to just get it in, the form that we're used to. So we know that 9 can be written as 3 square. We know that 4 can be written as 2 square. So in the next line, just applying some indices, you can actually put these two together using the same square. And from here, you would have won the game. So you have something squared minus something square. Hence, difference of 2 squares, right? Once that is the case, then the answer is just whatever is in the, just as before, we had a square minus b square. Now we have 3a square minus 2y square. So we just put the sum of them in bracket, and then the difference of them in bracket. And that's it. So moving on to another question. So for this one now, it's not like the one before where you had square numbers and we could just apply this here. No, we have 7 and 28. The best move you could make here is to just try and, you know, put factorize, and by finding the common factor, which would be 7, you put the 7 outside the bracket, and now you have, so 7 4 is 28. You have a situation like this. Now you have a square number here, so all you have to do, you have 7x squared minus 2 squared. And we're very familiar with setups like this here. So all we have to do is to say, okay, the answer here is just x minus 2, or plus 2 if you rather have it that way, and then x minus 2. So it is 7 x plus 2 times x minus 2, and that's it. Now for our last question, you know, we have a cube. You know, we have been working with squares, so you know what to do. Well, first thing you can do is to put the common factor outside, the highest common factor, which is p, outside a bracket. Now you have p squared minus 1. Now think of this one as 1 square. So you have p squared minus 1 square. So p, so you can just, you know, apply what we did before, and your answer is just p plus 1 times p minus 1, right? So we bring back the p and then factorize the p squared minus 1, which results in p plus 1, p minus 1, and you're finished. So that's it for factorizing the difference of two squares, and as the name suggests, you know, it's a difference of two squares. Like if you had a plus sign here, all that we have been doing couldn't work. See, if you look at the questions, minus sign. So if we had plus signs, it couldn't work. You know, even, you know, bringing back what we did, difference of two squares. Alright, so we have been just working with minus signs. So in the next video, we'll be looking at factorizing quadratic expressions. So, you know, best of luck.